you look at this question, it's interesting because what you have here is you have a variable x being multiplied by another variable expression. So you have a variable times a variable, and that is going to require a product rule. And again, if you were to think about this, like in front of the cosecant x plus 1, this x is not just a coefficient. It cannot just tag along, so you need to go through the product rule. So our product rule is going to have the first function as x, and then our second function is going to be cosecant x plus 1. Now, the first function's derivative is just 1. The second function's derivative, remember, if you differentiate a c function, it is negative. So the cosecant is going to go to a negative. And then for cosecant, you need a total of 1 cotangent and 2 cosecants. So this, I have 1 cosecant, so I'm going to need another cosecant and a cotangent x. And then the plus 1 is going to go to 0 because it is a standalone constant. Now, with the product rule, we multiply these diagonals, and P is for plus, we add them together. So when I plug into the product rule, that is me taking the derivative. So it's no longer going to be that this is y, this is now going to be y prime equals, and then plugged into the product rule. So my derivative is going to be cosecant x plus 1, and that is 2 terms, so technically I should put parentheses there. However, it does not matter for this particular question because we have a times 1, so we could just write it without the parentheses if we wanted to. Then it's plus x, and here I have a minus, so I'm going to put that in parentheses and say it's negative cosecant x cotangent x. Now, anytime you have a negative coefficient, we always want to move that to the front of the term. So we would move our coefficient, if we had any coefficient, to the front of the term. So what I would do is I would move this to the front of that term. Now let's talk about simplification here. This parenthesis here is completely unnecessary because, again, the first power, first coefficient here. So you could drop those. And then this parenthesis is also unnecessary because this is just one term. So you could write this as minus x and then cosecant x cotangent x. And there are no like terms to combine, and so this would be your final derivative.